Hey everyone. So today I wanted to talk about MCP architecture and MCP design. So the reason is that most MCP servers are built backwards. So we take an API, we wrap every endpoint as a tool, we hand those tools to an agent, and then we wonder why the trace turns into a mess. And not only a trace, but actual intent is not met. And that works for a demo, this type of thin design, but it breaks down the moment the agent has to run a real workflow. So in this video, I want to walk you through how I figured that out the hard way on a Gmail and calendar MCP server that I already shipped for my client. So the rebuild changed the way I think about MCP design entirely. By the end of this video, you should be able to look at your own MCP servers and tell whether it's actually a workflow boundary or just a thin coat of paint over an API. So let's dig into it. Before I tear, into thin wrappers, I want to be fair to them. Thin wrappers are not stupid. They hide credentials, they scope sessions, they separate reads from writes. They make the very first integration possible. And if you are at the stage where you just need an agent to touch a new system at all, a thin wrapper is the right starting point. But the mistake is letting this thin wrapper become the production abstraction once one agent owns one vertical workflow. And the moment you have a real job to do, the API shape stops being the right shape. So my worked example here is a Gmail and calendar server. I'm going to keep this provider agnostic on purpose because the lesson is not about the Gmail. The lesson is about what happens when an agent has to grind through a real inbox to do some real work. Here's the moment that changed my mind. This is an anonymized trace that I got from a real work of the agent. And, it was not a design review, it was not a blog post, it just was a trace, like a simple trace that I saw. And before that split, one run of the morning pipeline review, and this is a pipeline review that it's like a background test that we have in our agent. It looked like this. It made like a ton of tool calls. It spent almost 2 million tokens, and it ran like for so much time, like almost 15 minutes. But after I redesigned the MCP boundary, the same workflow looked like this. It made only 26 tool calls. It ran for 5 minutes, and it became like 3 times less expensive in terms of tokens. And I want to be careful here. The point is not that you should expect this exact delta on your workflow. The point is that the trace is the thing telling you that the abstraction is wrong. If you are not reading your traces as product telemetry, daily, or at least like a few times a week, you are flying blind on your own MCP and agent design. So the first step is not to add more tools. The first step is usually to read what you already have. So treat the trace as product telemetry, not as debug output. When you read a trace, look for 5 specific things. That's usually how I look at the traces. Look for loops. The agent is calling, the same tool with slightly different arguments over and over. Look out for repeated body reads. So agent pulling the full content of the same object more than once. Parent context bloat. Giant blobs of raw data piling up inside the parent trace, and this is where they were never going to be useful. And one of the most, I think, obvious thing is you have to look for repeated missing evidence. So agent keeps rediscovering the same policy or the same edge case run after run. And of course, look for errors the model worked around silently. So those are the most dangerous because they look like success. Which tool dominates the trace? What raw objects are entering the parent context? Which policy is being rediscovered inside every run? So those are the questions that if you cannot answer them about your own MCP server and agent, this is the first step you need to do. You need to answer those questions. So step 2 is to sharpen the contracts on the tools you already have. And this schema, it tells the agent what is valid, basically. So the description tells the agent what is safe. The failure taxonomy tells the agent where the recovery is even possible. And pagination protects the context budget from a single bad call. And just wanted to remind you that it's all about the emails. And in our use case, agent had a lot of emails to crunch through, and this is why we basically build this MCP server this way. So just wanted to point out that a tool with a vague description and an unbounded response is not really a contract. It's an invitation for the agent to take guesses. And guessing is what produces those silent error loops we just talked about. I'm not going to spend time here on TypeScript or mechanics. If you write tools at all, you already know how to define a schema. But the question is, I want you to ask is whether the schema actually constrains the behavior or whether it just types the arguments. That's also a really good question you have to ask yourself. And moving further is third step, and it's evals. And evals is my favorite thing, to be honest. Specifically evals for workflow failures that not just answer quality, this mysterious agent quality. Here's what I mean. The answer can look perfectly useful and still violate the workflow contract. The model can return a clean summary of your email, then quietly skipped some required sources or some other emails, but it confidently presented you this summary. So the problem with that is that it was never grounded in evidence. So for a toy demo, that's pretty good, right? But when we're talking about a real workflow system, a system that is in production, that is deployed into a real workflow and into real company, that's pretty good. But the evidency policy it was violated, and it's a bug. It's the kind of bug that erodes trust the moment a human spot checks the output. And your evals should test the operational policy, not just the final prose. It should ask these evals should ask, did the agent cite the right messages? Did it respect the approval gate? Did it stay within the worker, or did it pull raw content into the parent? And those are like the assertions that keep the workflow honest. So moving to the fourth step, this is where the architecture really starts to change. We move the grind into workers. The parent agent should decide. It should synthesize, it should ask for approval when needed, it should write the final brief that a human reads. The parent agent, the most intelligent one, kind of like GPT 5.5 or Opus 4.7. So the parent should not personally grind through all of those emails. Every thread message on every one of them and every attachment candidate. It's not a judgment work. This is just like an extraction work. And a worker can be boring. It could be just like a pretty dumbed down model, something like even Haiku or Sonnet or GPT 5 Mini or even Nano. And a worker can be, entirely contract driven. And a worker can return a tight structured packet instead of a wall of raw content. And that distinction I want you to hold in your head is this. The worker owns extraction coverage, the parent owns the judgment. And even for that extraction coverage, you can create skills. So these less intelligent models can, figure out like what is the exact, contract and what is the exact step-by-step instructions for them to follow. So once you draw that line, a lot of the trace flow just disappears, because the parent is no longer being asked to look at things it was never going to use. Moving on to the step 5, it's the one that took me the longest to internalize. Replace tool with process, replace tool menus with process tools. So the workflow I was building was never really to read email. The workflow was to run a morning pipeline review for an agency managers. And think of this morning pipeline review as like an action item list of what's on their plate every day. Who they need to follow up, like what are their stale deals, what they need to do. And the tools like read email and morning pipeline review, those are not the same thing. One is just like an endpoint, and the other is a business process end to end. And if the business process has a stable shape, the MCP boundary should expose that shape, not the underlying API surface. When I look at this input shape, I'm not asking the agent to compose a sequence of low-level reads. I'm giving it a single tool that already knows what a morning pipeline review looks like, what's the contract behind it, and the filtering, the windowing, the evidence rules, the pagination defaults, all of that lives inside that tool. And the agent gets to operate at the level of the workflow, not at the level of the single inbox. So this is the move, and I'm thinking, yeah, that's how I think now about the building MCP architectures, like from tool menus to process tools. So let's pull all of this together. And again, MCP gives you tools, right? Resources and prompts. Production workflows usually need all three. And the MCP server is the right home for a surprising amount of operational knowledge. Source authority lives there, permissions lives there, provider normalization lives there, context compression lives there, pagination defaults live there, evidence, approval gates, trace logging, eval hooks, you name it, like. And here's the core sentence I want you to take away from this video. If you leave policy in the parent prompt, every run has to discover it. And if you move policy into the boundary, then every run benefits from it. So that is what makes an MCP server feel like an infrastructure instead of a wrapper. So when you are designing or redesigning an MCP server, ask yourself these 6 questions. Is this tool exposing an endpoint or a workflow step? What evidence does this workflow actually require? What should never enter the parent context? What belongs in a worker in terms of context and tools? And what should be a process level tool? And of course, what eval proves that the contract is working? And I just think that the mistake is treating MCP as a clean way to expose endpoints. The better version of is that we need to treat MCP as the boundary where your operational knowledge becomes executable. So tool is second and process is first again. Thanks for watching. Please subscribe if you like this video, and yeah, stay posted.